All right, chapter number 3, problem number 66 reads, the longest recorded pass in an NFL game traveled 83 yards in the air from the quarterback to the receiver. Assuming that the pass was thrown at the optimal 45-degree angle, what was the speed at which the ball left the quarterback's hand? All right, so I've drawn a little picture here where we have our quarterback throwing the ball to our receiver. We'll kind of assume that really the ball leaves at one height and it reaches at the receiver at the same height, make the life a little easier, and that they're 83 yards away. 83 yards is a nice, it's nice, it's far, but it doesn't help us because everything that we know is in meters. So what I did was I converted 83 yards into meters to find that about 83 yards is about 76.6 meters. Because again, everything that we're using the units that have to do with meters, kilograms, all that fun stuff. So we're going to make sure we are working in those international system units. Okay. So we would like to find out here, they're asking us, at what speed did he have to throw that football? Okay. So if we look at what we've got here for information, we have information in the x direction, and we need to find that speed. So because we don't really know information in the x direction, that's kind of where we have to start. So I'm going to go with x equals x sub o plus v sub o x t plus 1/2 a t squared. All right, and looking at things that we can work with, we know that x is the distance that the ball traveled to go from the quarterback to the receiver. That is 76.6 meters. Okay. If we take the origin to be at the quarterback, then x sub o is 0. Now, the football was thrown at an angle of 45 degrees, so that means the football is going to have an x component of velocity and a y component of velocity. Because we're looking at the x component of the velocity, that uses the cosine term so that we can get just the x component, right? So that would be equivalent to v sub o times the cosine of 45 times t, right? And then this acceleration term is 0 because, again, nothing is causing it to change its speed in that direction. Now, if we look at what we've got here, we have one equation with two unknowns. So we need a second equation. Right? We need a second equation if we're going to solve this problem. The only place we can go if we're stuck in the x direction is we need to go into the y direction to help us find out some more information so we can solve this system of equations. So I'm probably going to go with y equals y sub o plus v sub o y t plus 1/2 g t squared. So if we're taking the height of the quarterback to be the origin, we call that 0. We have to take a bit of a leap, or a bit of an assumption that the receiver is going to be at the same height as the quarterback, so the ball is going to end at the same height. If we do that, then we can say that the height that the football ended its flight at is 0. We can also say that y sub o was 0. If you wanted to, you could call them 2 meters for the start, the height of the quarterback. If the quarterback is like 6 feet tall, and you can do the same thing for the height of the receiver, but the math ends up working out anyways, so we just call them zeros. Now, v sub o(y) is the initial speed in the y direction, and that then is v sub o times the sine of 45. Okay, and then we've got t plus 1/2 negative 10 t squared. Alrighty, so we've got some stuff working out here for us now. We do a little bit of work, a little bit of math. We can get that the sine of 45 is 0.707. And if I take this over here, we can bring it to the other side of the equation. So 1/2 of negative 10 is negative 5. Bring it to the other side, we get 5t squared. All right, the sine of 45 is 0.707 again, so 0.707, and then v sub o times t. From here, we can cancel out a set of t's, so we get 5t equals 0.707 times v sub o, or t is going to be equal to 0.1414 V sub O. Now we can take that information and we can plug it in here for t to get our final countdown, right? Our final work done. So we're left with now 76.6 is equal to V sub O cosine of 45 times 0.1414 V sub O. Right? We do a little bit of math. Here we come out with 76.6 is equal to 0.0999 V sub O squared. And doing our final bit of work, we find that the quarterback had to throw the football with a speed of 27.7 meters per second, which is pretty close to 60 miles an hour. So that's pretty good, Chuck. That was chapter 3, problem number 66.